So we are going to complete the one-step and two-step equation notes for today. Oops. So find the page that matches this screen. So a lot of this is a review from a few years ago, at least. So this first section we're going to go through pretty quickly. The goal of solving equations is to determine the value of the variable. So number one, I need to find out what m is. Now, depending on how your teacher presented this to you throughout the last few years, the method that you'll hear me speak about is a strategy that will put you in a situation where you shouldn't run into a lot of problems. There are certain methods that middle school teachers will teach that don't necessarily work as well once you get to more complicated equations. For example, on a problem like number one, a lot of teachers in middle school might say, well, if you have an addition problem, we're going to subtract. That doesn't work all the time. It might work all the time in seventh grade with the type of problems you would see in seventh grade. But once you hit pre-algebra, you'll notice that that doesn't always work. Once we get to algebra, it still doesn't always work. So what you'll hear me say is whenever we have addition or subtraction in our equation, we want to find the constant and make the constant become zero. So this constant, positive 12, we want that 12 to become zero. To make it become zero, I subtract 12. I'm going to do that from each side. And I get m equals negative 2. And that's my answer. Number two, I need to get the constant that is with the variable. I need that to become 0. So negative 9 has to become 0. That's the goal. So I'm going to add 9 to each side. G equals 7, or 7 equals G. Now with multiplication and division, we're looking at a coefficient of the variable. So in this case, I have to get rid of my negative 7. If I can make that negative 7 become 1, if I can make this 1y, that's the same as y. So the goal is to get rid of that negative 7 by making it the value of 1. In order to do that, we're going to divide by that number. I'm going to divide each side by 7. Excuse me, negative 7. And we get y equals 13. Number 4, the 9 is being divided, so it's a divided by 9. To undo division, we multiply. It's an inverse operation, so I'm going to multiply each side by 9. These 9s cancel. The reason we know they cancel is if I made this a fraction and we multiplied, it would be 9a over 9, and then these 9s would cancel, right? So we get a equals negative 36. So the next section, fractions. So if you have a fraction as the coefficient, okay, so up above here on number 3, we had an integer as the coefficient, and we divided each side. Now, as we have a fraction, if you can imagine trying to divide each side by 2/3, it gets real weird. Trying to divide by fractions, it's just strange. So what we're going to do is to get rid of a fraction multiplied by the reciprocal. This word came up in some of our review in prior lessons, so hopefully that word rings a bell. The reciprocal is when you flip the fraction. You won't hear me say flip, you'll hear me say reciprocal. It's the correct vocabulary. However, a description of that word is that when the reciprocal flips. So for number 5, just like number 3, the goal is to make the coefficient become 1. Okay, so I need this fraction to become 1. A way to make it become 1 is to multiply by the reciprocal. And I'm going to do that on both sides. The 3's cancel and the 2's cancel. The reason I can do that is if I were to actually multiply, I get 6 over 6x. 6 over 6 is 1. The whole point of multiplying by the reciprocal is so that our fraction on that side, everything cancels. So we are left with x equals 30 over 2. So our final answer is x equals 15. Now you could have cross-canceled like this, or you can just multiply across 10 times 3, 1 times 2, and then simplify at the end. You need to make sure that any fraction that you get gets simplified. Number 6, same process. I have a fraction for my coefficient, so I'm going to multiply by the reciprocal on both sides. These cancel, and we get w is negative 72 over 4, which is going to simplify to negative 18. Definitely use your calculator. If you use the calculator and you get a decimal, then that means you need to just simplify the fraction. Do not answer with a decimal unless it's a decimal that ends in your calculator. If the decimal does not end and you have to round it, do not write your answer as a decimal. So an example is if your fraction is 1/4, that becomes 0.25. That's okay. But if your fraction is like 1/3 and it's a repeating, you can't write 0.3. That's not equal to 1/3. 0.3 is 3/10. 3/10 is not 1/3. So the minute you have to round or there's a repeating situation, do not answer with a decimal. Number 7, again, we are going to multiply by the reciprocal. In this case, we have a negative. The reciprocal of a negative fraction is a negative fraction. So we're going to multiply by negative 5 over 6. Now on a side note, this negative sign is in front, kind of in the middle of that fraction. You can keep it in the middle. You can assign it to the numerator or the denominator. It's up to you. So on the left, my numbers will cancel. A negative times a negative is a positive. We get negative 100, not 100, negative 60 over 6. It's okay, equals negative 10. Number 8, again, we're going to multiply by the reciprocal. My fractions should cancel, and we're going to get m equals positive 18. be 18 over 1, which we just write as 18. To solve two-step equations, most of the time this is going to be your process. Step 1, undo the addition or subtraction. Remove the constant term. We're going to be making it 0. So the constant term is going to become a 0. Step 2, undo multiplication and division to remove the coefficient. We want to make the coefficient 1. Okay. So number 9, step 1, remove the coefficient. Here's our coefficient, positive 8. I need to make positive 8 become 0. Minus 8 from each side. Remember, whatever you do to one side, you need to do to the other. On a side note, you'll see me kind of draw a line through the equal sign to remind us that there's a wall there. I can't just move stuff. I have to take it off of the one side to get it to the other side by using inverse operations. If it's a positive 8, I subtract. If it's a negative 8, I add, right? So that becomes 0, and I get 6x equals 42. Now this coefficient needs to become 1, right? The goal is to make that become a 1. To make 6 times x, to make the 6 become 1, I need to undo the multiplication by dividing by 6. X equals 7. Number 10, same process. We want the constant to become 0 to remove it. My constant is a negative 5, so I'm going to add 5. Now what you'll notice, it's kind of subtle, but I'm circling the constant, and when I circle it, it makes it look like a 0. So that's my like muscle memory notation way of reminding myself that this number has to become 0. If that helps you, beautiful. That's great. So I'm left with 2n equals 16, right? That cancels and makes 0. I need this 2 to become 1, so I need to divide by 2 on each side. N equals 8. Number 13. We want to look at the side that has the variable, right? So on the side that has the variable, I'm going to get rid of the constant first. It's a positive 9, so I'm going to subtract 9. I have to do that from each side of our equation. And I get 4 equals negative 4k. I need to make this coefficient become 1, so I'm going to divide by negative 4 on each side. Remember, the number that has to become 1, the coefficient, we're going to divide by itself. So I get negative 1 equals k. Now, number 12 is a problem. At the very beginning of this lesson, I made a mention of, sometimes in middle school, teachers will teach if it's a subtraction problem, you add, and if it's an addition problem, you subtract. But that doesn't always work. This is one of those cases because what you see here is a subtraction problem. So a lot of students are going to think, oh, well, then you just add 7 to both sides. If you did that, now don't copy this down, but if we added 7 to both sides because of this, think about it for a second. 7 plus 7 is 14. So I would have 14 minus 3y equals 41. That's no good. I didn't do anything wrong, but this process did not get me any closer to the solution. I actually created a bigger problem. Okay? So you have to be very careful, and hopefully this was dealt with in pre-algebra, because you should see something similar to this in pre-algebra. So hopefully you were able to get to the point where you, instead of focusing on the operation that's happening, you want to focus on what you're trying to get rid of. I'm trying to get rid of the constant. Whatever the constant is, I need to use the opposite of it. So the opposite of 7 is a negative 7 or minus 7. So we need to subtract 7 from each side. So you want to focus on the sign of the constant, not the operation in the problem. Those cancel, and I'm left with negative 3y. Remember, a subtraction sign is just a negative, equals I don't know why I just can't do math. 34 minus 7. My brain just completely, the mental math portion of my brain just stopped working. 27. I felt like that's what it should be. I don't know. Sorry. So now I have a coefficient of my variable that I've got to get rid of. This negative 3, I'm going to divide because undoing multiplication by division. Right? Add my little wall. So y equals negative 9. Okay, so this should be major review. As we go through this, if you're struggling on any of these, especially now on this backside, we're seeing some fractions involved. In Canvas, under the note page or under this video, there will be other videos that could possibly be helpful to you. So 13. Yes, there's a fraction here. No, don't get nervous. There's help on the front page. I'm going to walk you through it. Don't worry about the fraction until we have to worry about the fraction. First step is to undo the addition or subtraction, right? So we're going to get rid of the constant first. So in number 13, my constant is negative 7. So I need to add 7 to each side. So I get x over 2 equals 16. Now x and 2 are being divided. So I'm going to undo that by multiplying. And we get x equals 32. Right, because those 2's are going to cancel. Number 14. Oops. We're going to focus on the constant first, get rid of the constant. I get 3 equals c over negative 5. Multiply both sides by negative 5. That's going to cancel that denominator, right? So c is being divided by negative 5, so I'm going to undo that by multiplying by negative 5 on each side. So we get negative 15 equals c. Now 15, we have a fraction as the coefficient. Still not worrying about that until we have to. We're still focusing on the constant first. So get rid of the constant first. I want that constant to become a 0 because anything plus 0 is itself, right? It's that identity property. So we get 3/5 x equals 6. To eliminate a fraction that's the coefficient, we multiply by the reciprocal. Right? So don't forget there's a little 1 under the 6. These are going to cross cancel. So we get x equals 30/3, which becomes x equals 10. Now again, on a side note, you don't have to write the 30/3. You could cross cancel in this section right here. 6/3 becomes 2/1, and we could get the 10 that way. Okay, so we had this on the front side, but if you need to make a note, so to eliminate a fraction coefficient, multiply each side by the reciprocal. And pause to copy that if I go too fast. So for problems like 15, to eliminate that fraction coefficient, multiply each side by the reciprocal. So we're going to see this in 16, but we're not going to deal with that yet. We're going to start with the coefficient. If there's a coefficient, not a coefficient, the constant. If there's a constant, we get rid of that first. It's a positive 1, so I'm going to subtract 1 from each side. I have a fraction coefficient, so I'm going to multiply by the reciprocal. If your fraction is negative, the reciprocal will also be negative. Now 3/1 is, or negative 3/1 is just negative 3, right? So these guys are going to cancel, and I'm going to get m equals positive 24. Positive 24/1 is just 24. (17) Same process. Eliminate the constant first. We have a negative 10, so we're going to add 10 to each side. 7/4p equals negative 28. Our coefficient is a fraction, so we're going to multiply each side by the reciprocal. These cancel, and we get p equals, again, I'm taking the long way and I'm multiplying across. You do not have to, but we're going to get 112/7, negative 112/7, which becomes negative 16. And you do have a calculator, but this is a moment where being able to simplify before you multiply can come in really handy, because 112/7 is big. Yeah, you have a calculator, but if you didn't for some reason, if you look diagonally here, if I imagine that as a fraction 28/7, it's a little bit easier mental math wise to say that you could simplify that, right? You know that would become 4/1. So what we can do is we can cross cancel, and I could say, well, 7 divided by 7 is 1, 28 divided by 7 is 4. So I would have negative 4 times 4 here, which gets me negative 16. So by cross canceling, it actually saves a lot of time from having a large number to deal with. But again, it's up to you. 18 is our last of this section. We're almost done. So I have a positive 9, that's my constant. So I'm going to subtract 9 from each side. I'm not even thinking of this right here. I'm not even thinking of that right now. I just know that I have a positive 9, so I need to subtract on each side. Okay. So we get 6 equals negative 1/2 x. You've got to make sure you're very careful. That negative or that minus has to come down. You cannot leave that off. That's where a big mistake will happen. Students will forget that there's a negative 1/2 or a minus 1/2. Now, even though my negative 1/2 is in front of the x here, I still know that I'm going to multiply each side by the reciprocal. Even though they're spread apart a little bit, that's okay, because with multiplication, we can rearrange anything. So I know that these will still cancel. So we're going to get negative 12 equals x. Don't forget, if your fraction is negative, the reciprocal will also be negative. Last part, watch out. The examples below are different in that the multiplication or division is actually done first. Then we add or subtract. And here's why. If you look at number 19, the constant is technically not 11. It's 11/8. Don't write this down, but if I were to take this fraction here and write it so that it wasn't like an expression over 8, I could rewrite it like this. x/8 plus 11/8. That's really what that is saying. So the constant is 11/8. And again, don't write this down, just watch. If you were to try to solve this, now you're dealing with fractions and you're going to have to get common denominators, and that's a nightmare. I'm not saying that you shouldn't do work with fractions, but it's just not efficient. There's a much more efficient way to solve this, where you can avoid a lot of the fraction work. Okay? That's where this comes in. Multiplication and division is done first. Okay, so here's how that's going to work. If I back up, you don't have to, you can just take a look. Look at number 4. You don't have to go to your page, look at my page. Number 4, we had our variable a with 9 in the denominator. And the way that we got rid of that, 9 in the denominator, was multiplying both sides by 9, right? The way to get rid of a denominator is to multiply both sides by that denominator. So, sorry, this is going to fly through. So to get rid of this denominator of an 8, I'm going to multiply both sides by 8. So I'm going to multiply this side by 8. And I'm going to multiply this side by 8. And I don't really need parentheses on this side over here. I put parentheses on the left side because I'm just multiplying everything over there by 8. It's really not going to make a difference because, oops, sorry, those 8s cancel. So here's what's going to happen. X plus 11 is left over on the left side, and negative 24 is on the right side. Now I get rid of my constant. So make yourself a note. Multiply both sides by the denominator. that's what we're going to do here. So number 20, we're going to multiply both sides by the denominator. Okay. So on the left side, my negative 2's are going to cancel, and I have n minus 5 equals positive 14. Now I can get rid of my constant. So I'm just going to write a little note, especially because when you're looking at this for like the quick check, if you have a note written to kind of describe what we just did, that might help you refresh your memory for the quick check. So multiply each side by denominator, which was negative 2, right? Then we're going to eliminate the constant by adding 5 to each side. So those words can kind of describe what we did here to hopefully help you as you're going through your practice and for the quick check. So pause to get that copied. 2 more. 21. Same thing that we've been doing. If you have an expression with a number in the denominator, multiply both sides by that denominator. So we get negative 6 equals, those are going to cancel, a minus 13. Now eliminate the constant. We're going to add 13 to both sides. Once we get rid of that denominator, this right here is just a one-step equation. That's all that is a one-step equation. Okay, so we're going to get 7 equals a. Last problem, 22. I have a 9 in the denominator, so I'm going to multiply both sides by 9. So I get 36 equals, my 9's are going to cancel. Remember, this is technically 9 over 1, and I'm going to cross cancel those 9's. We're not trying to distribute or we're not doing anything crazy. The whole purpose of multiplying by 9 is to eliminate the denominator. So don't do extra work. Now I have a one-step equation, so I'm going to get rid of the 8 by subtracting 8 on each side. We get 28 equals W. And that's it. Again, if you need more examples, if you go below this video, you'll see these same notes done by a different teacher. They may go through it a little bit differently than I did. Maybe something will make sense differently than how I went through it. There's also other videos below just with different teachers on YouTube going through these type of examples. So that's it. Start working on your practice problems.